And is it on video? Yesterday, one of my classes, it was inadvertently on camera. So I laughed because apparently took a picture, and one of the things that showed up was, so 90 minutes of that, if I wasn't careful. And so the person he goes, oh shoot, I accidentally put it on photo. So we didn't lose too much time, but it was kind of funny when I'm downloading stuff going, why is there a picture of me just standing there? Okay, today we're going to talk about how to actually effectively sample. That's going to be the starting point. And this is not an obvious thing. So, same question I had last day. We want to find out the average height of a Mesa College student. And that's certainly a reasonable goal. Yeah, and there's a lot of reasons why you would want the average size of a Mesa College student. Think about the desk you're sitting in. Is this desk, for anybody here, is this desk either way too big or way too small? Anybody? I had a student over the summer. He stood at a table the whole semester. The desks were too small. Think about that. He's a defensive lineman on the Mesa football team. He's over 300 pounds. And it was like you needed the jaws of life to get him out of one of the desks. It was so awkward and uncomfortable for him. So after the first day, he said, I can't sit in the desks. And I said, that's fine. That's not a problem. So were these desks made for that guy? No. Now you might have somebody, I have a couple of hobbits in my classes. And so when they're sitting there, their feet, dangle. Do any of your feet dangle? I don't think any of your feet dangle. I've actually had students where their feet dangle. That's kind of funny. So these desks look like, they're gigantic. But for most of you, these desks are perfect size, aren't they? They're very comfortable and everything. Do you think some thought went into designing the size of this desk? What do you think went into the design? Why isn't it bigger? Why isn't it smaller? Why is it exactly this size, do you think? Well, I'm going to tell you something. These desks were not practical for a long time. These were the desks we wanted to use for many years. You guys weren't here before this building. I was here generations before this building. The old H building, which is now gone, most of the classrooms were in there. In those classrooms, we had roughly 50 chairs, but the classroom was maybe 2/3 this size. So you guys have seen those desks. We don't have any in here. You've seen the desks where you get in the lefty-righty desks, and they tip over real easy. You know what I'm talking about? The really light ones. All of these rooms seem to have a few of those holdovers. That's what students sat in. They were significantly smaller than these, and the reason they used those is that they could have room between the rows. They couldn't put more than about 30 of these chairs. You say, why is that a deal? Well, there's something called the Americans with Disabilities Act that became federal law in 1990. It's about equal access. Do you know there is a law that governs how far apart these seats have to be? Did you know that? Does anybody want to take a random guess at the reason there's a law? Simple.
So wheelchair?
Wheelchair access, exactly. There must be a minimum of 36 inches. When we tried to put these in the old building, we realized if we put the number of desks, they literally were touching. And we had an instructor, a full-time instructor for many years, who was in a wheelchair. He'd been in a wheelchair since he was a teenager. And on a daily basis in his classes, the students had to move desks out of the way so he could simply get to the front of the class. It was a real pain in the butt. He never complained. But the very fact that the instructor could not physically get to the front of the room ever without people moving things meant it was a bad setup. So these desks we've been waiting to use for years. These desks took a lot of time and trouble and research, but you know what they were based on? The average size of a college student. That was not random. That was a lot of research and a lot of planning, because these desks are all over the country. So we want to find the average size of a Mesa College student. Maybe it's because we want to market a line of clothing. Maybe it's because we want to come up with the next thing. Maybe it's because we're redesigning the cafeteria and we want the seats in the cafeteria to be able to be accessible to the vast majority of students, not the extremes. And that's one of the things about statistics people forget. It's not about extremes. There is always going to be a tallest, a shortest, an oldest, a youngest, a richest, a poorest, right? There's always has to be somebody in the extremes, but what we want to do is figure out where does the majority lie? Where are the masses in a sense? So you want to figure out the average height of a Mesa College student. So let's say you've decided, if I get a sample of a size 100, that'd be a pretty good sample. I don't need 5,000. But if I could get 100 people at random and find out how tall they are, that would be great. So how would you do that? Would you just hang out here at this building and just Say, hey, how tall are you? First of all, the problem with how tall are you? How many's height on their driver's license is exactly correct? How many is exactly correct? Or is it your height when you were 16? And maybe you're taller. Anybody that? How many are that person? Okay, I hit 5'9" ¾ to 7/8 at about 16, 17. That was tall. So my driver's license says 5'10". I'm not 5'10". I wish I was 5'10". I wanted to be double digits. I'm almost 5'10". A couple of years ago, my physical, I was still 5'9" and a half. I think I'm probably 5'9" at best now, with gravity and things like that. Point is, if you ask me how tall I am, I'm going to say 5'10". If I ask you how tall you are going to tell me how tall you are or how tall you want to be. Let me put it another way. If I ask you how heavy you are, am I going to get the truth from anybody? Probably not a lot of people. We're going to probably, a lot of us go downwards, right? So the point is, first of all, you can't ask people how tall they are. You're going to get very inaccurate information. So you're running around campus and you got a little measuring thing. Okay, it's going to take just a minute. Can I measure your height? Sure. So you've decided to ask people, as they're maybe entering and leaving this building. I want to find the average height of all Mesa College students. Do all Mesa College students have classes in this building? No. Maybe not. So we want to talk about the most important type of sampling because it's the simplest. It's called a random sample. In the textbook, the author refers to a random sample and something called a simple random sample. They really are the same thing for all practical purposes. A random sample, let's suppose you want to pick a sample of size 100, that's fine. Then any group of 100 people on campus has to be equally likely to be chosen, meaning every single individual on campus is equally likely to be chosen. That way, when they don't pick you, you're not upset because you were just as likely to be chosen as the next person. You just weren't because we only picked 100. So we talk about opinion polls, right? We talked about that last day. Well, they didn't ask you, but they did a random sampling, so you were actually a possible person. It was possible they could have chose you. They just didn't. A random sample is something where everybody's equally likely to be chosen. So if we only sample from people entering and leaving this building, are we leaving out a lot of the campus? Yes. And by the way, when are you going to do your sampling? Well, I'm going to do it right after class. What about the evening students? What about the Monday, Wednesday students? Ooh, do you see a potential problem right off the bat with trying to do the sample? So every class I ask the same question. How would you do it? First of all, do you need to do all of it, or maybe can you have a team? So I'm going to get some friends. 10 of us are going to do it. And so we'll all be stationed at the math building, right? How about stationed throughout the campus? Like the SB building, cafeteria, the exercise science building. Oh, okay. So how about stationing 10 people around campus? So let's say you ask somebody at 8 o'clock. Great. There's a lot of people here at 8 o'clock. Are those same people here in the afternoon typically? Are the people that are here in the evening ever here at 8 o'clock in the morning? No. So you'd have people all over campus throughout the day on Tuesday, Thursday. How many of you have all your classes Tuesday, Thursday? Okay. Do you think there's people who have all their classes Monday, Wednesday? Yeah, most of my Monday, Wednesday students only have classes on Monday, Wednesday. So if you're going to do Tuesday, Thursday, you're excluding half of the campus. Oh gosh, this is so complicated. So do you see where I'm going? You've got to be all over campus, all day, every day. Now, if you are randomly selecting people, is this sample going to be more likely to be reflective of the population at Mesa College? Yes. The moment you pick a particular place, a particular time, a particular day, and say, I'm going to do it then you exclude everybody who wasn't there at that time. And that's not a good sample. Right? That's a sample that only reflects that particular segment of the population, but not the whole population. So that's why you cannot go around and say, I'm going to pick you, and I'm going to pick you, and I'm going to pick you. I've already decided. That's not random. You never had a chance. Oh, so then how do you select people? Well, there's a lot of ways you can do that. I mean, there's random draws. So I got a thing in the mail that says I have a free cruise coming up. You guys ever get those? You know, 3 days, 2 nights, I just have to get there. I have a free cruise. So what I decided to do, because it said 3 people can go, I'm going to give it to you guys. Randomly, 3 of you. So I'm going to randomly select you and you and you. Wait a minute, I just selected you. That wasn't random. You never had a chance. You never had a chance. That's not random, is it? I don't select people. How could I fairly pick 3 of you for this cruise? What do you think?
Draw names from the hat, maybe.
Perfect answer. That is the absolute simplest thing humanly possible, and it is the most accurate. Everybody writes their name down maybe on a little 3x5 card. And we put them in a pillowcase, put them in something you can't see, we swish them around, we pull 3 names out. What do you think? Did all of you have the same opportunity to be chosen at that point?
Yes.
What if I stacked it and I put 10, you got in there 10 times? And I somehow left yours out completely. No, that's not fair, because you never had a chance and you had way more opportunity. No, the simple random sample would be everybody's name went in the hat and I picked names out without seeing the names. Now nobody could say that the drawing was unfair because everybody was equally likely to be chosen. Does this work in general though? If you have a large group that you're sampling from? I want to select 100 people at Mesa College. Pre-pandemic, we had usually between 27 and 30,000 students on campus. Right now, our numbers are way down. But I think we're probably closer to the 20,000, maybe even less. But still, you want to put 20,000 names in a hat or in a box, you realize the impracticality from the sheer size of the population. That may not work. But perhaps I could go to the Mesa College computer that has the entire list of all students on campus. That would be one way, and then randomly select that. There's a whole bunch of ways, but you guys got the idea. Now, I want to measure people's height, so that means I have to do a good job. I have to be accurate. I can't let somebody tell me their height. I actually have to have the right height. Okay? And the thing is, we want to do this right. We're very sciencey, so I want to find the average height in millimeters, which is great. Do you know how tall you are in millimeters? Does anybody here know how tall they are in millimeters? Yeah, probably not. But that would be a really good way of doing it. So if I ask you how tall you were in millimeters, I probably am not going to get an accurate response. So I'm going to measure you. But I have a yardstick. Is that going to work? No, there's no millimeters on the yardstick. Okay, I'll do it in inches and I have a yardstick. It's still not going to work unless you're all under 3 feet tall. So I actually have to have the proper tools. And a lot of times when we're doing measurements, we don't always have the proper tools, and so the numbers might be iffy. Man, something as simple as finding the average height of a Mesa College student, this can be really difficult. Now, this is the simplest way that most people think about. Now, let's say hypothetically, about 50% of the campus is male and about 50% is female. I don't know what the numbers are today, but it's probably not much off that. So you do your random sample of 100 people. You did everything right? And your sample had 75 women and 25 men. But you absolutely were random in your selection. But you got 75 women and 25 men from a campus that's about 50-50. Does anybody see a problem with this? Or is this totally okay? Because it was random. Everybody was equally likely to be chosen. You don't like that, do you? Why not?
Because I'm not sure.
Well, okay, first of all, in general, is the average height of a male or a female taller? That's a terrible way of asking the question. Who's taller in general, men or women? Men, for a few inches taller. So if my sample is heavily dominated by females, what's that going to do to the average? Is it going to over-report it or under-report it, do you suppose?
Underreported.
Probably under-reported. So if the campus is roughly 50-50 and I did a perfectly random sample, what do you think?
So you probably would it would be bad to do it actually random. I think you should do it specific, and then it would seem more random. For example, you would choose that there has to be this set amount of males that are chosen and this set amount of females.
Good, that's a good start. This is what, okay, there's a lot of different names for this type of sample, but this would be the sample where we would want the right percentages to represent the population, okay? And if you think about this logically, I still want to randomly choose people, but I want it to be half and half. So as I'm randomly selecting males and females, once I reach 50 males, I won't select any more males. Does that make sense? Okay?
Yeah, if we looked at the numbers beforehand and there was like, and that it would be like 40, say that it was actually like 45% males, 40,
Sure.
55% female on the campus, would you do 55 and 45?
That would make more sense.
Yeah, okay.
Now, this type of sampling this is difficult. This one is probably the hardest type. I think I'm trying to find the textbook. I found like one place where they just did very little. But this is what is called, stratified. Stratified. A stratified sample. When they're doing political polls, this one always makes me laugh. Like when you're watching the news and you're really bored and they'll talk about a poll and they'll say, so-and-so got 83% of the 19-year-old Eskimo vote. You know, you ever hear things like that where they break it down so specifically as to one particular group and they go, wow, they dominated the 19-year-old Eskimos kind of thing. Yet, is that a large percentage of the population? Probably not. But you'll always hear about the candidate. They got this percentage of the elderly women vote, or this percentage of the Hispanic vote. You'll always hear statistics like this, but what does that mean in the big picture? Because I don't know how that compares to the overall vote. It actually is a really silly thing to report that much detail. I got 83% of the people in this row vote. Who cares? But what they're doing is they're killing it because they don't understand. Stratified means you break up your sampling to reflect the population in terms of percentages in the way you want it to. So let's go back to male and female, because that's the easiest one. Whatever percentage of the population was male and female, that's exactly the percentage of my sample I would want. Did everybody understand that? Because anything else means I would overrepresent a particular group, and now my results absolutely would be biased. Now, what I don't do within that is saying, well, if you're tall or short, I'm going to exclude you. No, I'm randomly selecting, let's go with 45 and 55, like you said. Turns out I need 45 males and 55 females. But within that, they were randomly selected. But once I reach that quota, if you want to call it that, then you stop. Let's suppose I wanted to break it down even further. If I wanted to do it, let's see, this is a pretty young group. I have had classes where I had age differences in the class of 60 years, 60. I had a couple retired teachers come back and they wanted to take stats. I don't know why at 75 you'd want to come back and take stats, but they, I did that. They were off the charts good, by the way. Let's suppose I wanted a poll that age may make a difference in how you look at things. Okay, so I wanted an age cutoff. Are there natural age cutoffs in many, many areas in life? Think about, give me some natural age cutoffs. What's the very first one as you're growing up in life? What's the very first age cutoff?
Theme parks? Theme parks?
No, give me a number.
18.
Oh.
Maybe before then? A couple years before then, maybe? What's happening at 16? So maybe the very first major cutoff would be 16 over and above. In other words, you have your license, you don't have your license. Oh. Now then the first huge one clearly would be 18. You're an adult, you're not an adult. Is there another age cutoff nearby?
21.
21. Now, alcohol, not alcohol. Is there another huge one soon after you may or may not be aware of?
25.
25. What does that affect?
Rent a car.
Car insurance. 25. If you're under 25, you can have a perfect driving record, doesn't matter. You're still paying through the nose. You can be over 25, have a lousy driving record, you won't be paying as much necessarily. There's another one, strangely enough, 26. You know what happens at 26?
You gotta be on your own medical insurance?
Good. You're on your own in all forms of insurance. You're now cut off from your parents in most areas of life. I know this because I have somebody over 25 in the family, and at 26, they were cut off from my insurance. So they had to get their own. My gosh, there's so many places. Then after 26, it's pretty much, retirement's probably the next one. But think about these natural cutoffs. So if I was going to do a poll, and the poll was very specific to any area in life that was affected, maybe it's about alcohol, maybe it's about car insurance, Maybe it's about the ability to vote, so now it's 18. Then would it be wise to have my stratification use that age as a cutoff? This actually has happened multiple times since I've been here. There have been polls on campus to ask students, what do you think about us raising the fees to do the following thing? Oh gosh, many, many years ago. Again, you guys aren't experiencing it now because you're coming back post-pandemic, it's still pretty light, but parking was an issue on this campus forever. 8 o'clock classes, you had no problem. You came at 9 o'clock, you weren't gonna find a parking space. You often parked off campus and walked. Parking has always been an issue here, right? They built a parking structure, but you know, at any given moment, there's at least 10,000 people on campus, and you gotta have the parking. It's not due yet.
Oh.
Yeah, it's not due till next day. I'll talk about it, but good that you're done. So they put out a measure back in the 90s and saying, okay, if we raise the fees this much, we can afford to build a parking structure. Would you be interested in doing that? And the students overwhelmingly voted no. And when I asked the students, I go, you guys complain every day about parking, why not? And they said, well, I won't be here. By the time it's built, I won't be here. Why would I vote for such a thing? I said, you realize how short-sighted that is? First of all, do you have younger siblings? Do you think you might ever have children someday that attend Mesa College? That's kind of like saying, no, I don't want to worry about the environment. I'm not going to be here when the whole planet goes to, like what? So it got voted down every year. But there were several movements, again, many years ago, that people wanted a pub on campus. Now, how many have ever been to a university campus? Which university? SDSU. Is there a pub on campus? Yes. There's multiple pubs. UCSD, I did my first round of graduate there, my second at state. There are multiple pubs on campus. On campus. You gotta be 21 to go into the pub. And you go into the pub, you see a lot of your professors are just kind of winding down. No, having a pub on a university campus is, most universities in the United States have pubs on campus. Now, they're very strict about 21. They're not letting underage people onto the pub because it's a federally run thing. Yeah, they're not gonna take any chances. Well, you say, but universities, they're older than we are. Are they? No, community college average age is significantly older. It's not even close. We're 5 to 10 years older than university. Why? Because way more than half the students at Mesa are over 21. Way under half the students at university are 21. Only juniors and seniors. Think about that logically. I mean, most seniors are probably 22 at the oldest. I'm not talking about grad students. So why can he, so the move was, why can't we have a pub? And they would vote on it, and it would always overwhelmingly pass, by the way. But it turns out there's a federal law that says community college can't have a pub on campus. I don't understand it. I'm not going to argue, but I don't understand it. And it has nothing to do with age. Because as a campus, we are significantly older. How many here are 21 or older? I don't want to know your, yeah, this is a first year class, yet you guys are older. If we were at San Diego State, maybe one hand goes up, probably no hands go up, because everybody's taking this freshman, sophomore year probably. So we are already older, so you'd say, well, it makes sense. But when this vote would come out, they would always stratify it, not by male and female, by are you 21 and over, or are you under 21? Now think about that logically. Yeah, because if I'm 18 years old at Mesa College, why would I want to pay extra to have a pub on campus that I'm never going to be here to use? And I might not even agree with that it's the right thing to do. I might be absolutely anti. But if I'm under 21, it doesn't really matter. So the stratification by age is huge. So what if I want to conduct a sample that is not only gender specific, maybe in how you might feel, but also potentially age specific? So I might want to break it down male and female and age. Oh my gosh, then what do I do? Well, then I find out each percentage. Now, the percentages have to add up to 100%, don't they? So let's just say hypothetically that females under the age of 21 represent, let's just say exactly 30% of the campus. Then that means that 30% of my sample should be those people. Now, when I'm sampling though, here's the problem. I might be able to come up to you and go, okay, I know this guy's a male. That's not an issue. I don't know if you're over 21 or under 21. So I'm going to say, how do you feel about this issue? And you tell me, and I say, and can you tell me your age? Why? Because I got to put you into that category. I have room for one more person in that category, and I've run out in the other category. You're in the other category. And I say thank you for your service, but now I don't count you. Why? Because I already maxed out the other category. Everybody got that? So when you're doing a stratified sample, you will ask people and sometimes not count because you've exceeded that category. But you don't know that until you ask them. Sometimes the poll might be by political party. Because a lot of times, how you feel about something might be heavily influenced by your politics. Do you agree with that? So I'm going to say, here's an issue, how do you feel, what party do you identify with, and then I keep that tally. Now what I want to do is say, okay, how many Californians, let's say, are registered Republicans or registered Democrats, and let's just say registered other, because that kind of everything else. Then when I do my poll, that's exactly the percentage that I want. But when I look at you, I don't know what political party you're associated with, so I ask you the question, and then I ask you the party, and then I keep track. Does that make sense? It's actually quite simple, because then when I reach the quota of that particular stratification, I count no more votes. But I still ask people, because again, I don't know what party you're in. So I ask you the question, and if I haven't filled up that quota, then I keep going. When I filled up all the categories to the exact numbers that you preset, then you're done. So stratified sampling is by far the most accurate way to depict a population if the stratifications themselves might make a difference. Okay? This is another one that happened several years ago, and this wasn't about funds, because this one's supported by the government. We are technically, or I am technically, a state employee. I work for Mesa College, the college district, so I work for the state of California, not for the federal government. At the University of California, they're state employees, but there are parts of that that can be also federal. But I'm a state employee, and everything that is spent on this campus comes from the state of California. It doesn't come from your fees, it comes from the state's general fund, like the DMV and other things like that. So several years ago, there was a movement for childcare, because we are an older campus. Does anyone here have children? Okay, how old, if you don't mind? 5. Okay, so there was a time, maybe not anymore, but there was a time childcare was maybe a consideration that you had to think about, right? You can't just leave and say, okay, I'll just take off, kid, I'll be back in a few hours, right? Go ahead and feed yourself, or here's how you work the oven. It's probably not a good idea. So childcare on campus was a huge issue, and they were trying to figure out how to pull this off. So they'd ask people, should this sample be completely random of all Mesa students? Or where do you think the stratification should be here? What do you think?
Wouldn't it be like all people who pay taxes?
Not necessarily, because you don't have to pay for the services on campus. Again, that comes from the state. If they say we need these services, then they give us the money. But we didn't have childcare. So we want to get childcare, but that means that, think of it this way, there's an overall budget that we get. So if we now spend money on this, what does that mean? Somewhere else, we're not spending money. It's not going to cost you a penny, but somewhere else we're going to have to, what's the expression, rob from Peter to pay Paul? You guys ever heard that one? And so we only have so much money, but now, how do we even know if this is an issue? Well, we're going to have to ask the students what you think, because the administration can't possibly know. They don't know that you have a child unless you somehow told them. I don't know when you're filling out stuff if that's even something on the application. So where do you suppose the stratification here would be? Is it male and female? No.
Parents or not parents?
Perfect. Do you have kids or don't you have kids? Most of you don't have kids. Oh, now what if we did that and we found out only single-digit percentage of the population had? By the way, instead of having kids, how about having kids under a certain age? I have a lot of kids. They don't need child care anymore. In fact, they're going to be taking care of me pretty soon. So, I guess technically they'll be doing the child care. At some point, right? At some point I'll need someone to change my diapers, that kind of thing. Probably the stratification is not just people who have kids, but people who have young children. And I've had classes where I had many people in the class had young children, and they said the only reason they were even in college was because Mesa College had childcare. That is cool, by the way, in case you didn't know. That I could not have gone to college except that Mesa had childcare. I could drop my kids off there, I could go to school, I could pick my kids up, I could leave. That to me, that just that blew my mind when I found that out, because I didn't know for a long time, because that's really kind of kept secret. So when we're doing the stratification there, is it about political party? Is it about age? Is it about gender? No, do you have young kids or do you not have young kids? Because that would determine it. And if there's enough of a percentage that do, we'll say, you know what, this is a serious need. But what if a campus this big, let's just say there's only a handful of people with children? Then would we create this entire situation to have a daycare center on campus if there was only a few people with kids? Probably not. It probably wouldn't be necessary.
So, you said that like for this situation that it would be like people with kids would be the only ones asked, or
No. We need to know the percentage of people with kids.
Yeah.
So in other words, a stratification, you have to know ahead of time exactly how many are in each group. So again, we're going to do a poll on campus that might be gender specific or age specific. So you say, I'm going to ask this many people. Well, you need to know how many people are in this group. I need to know exactly what percentage of the campus is over 21 and what percentage is under. Because that will determine now how many I'm going to ask. See, I actually have to have these numbers available. Do we have these numbers available? Absolutely. The administration has your age, your cell phone number, your email. You know, do they know your political party? Do they know your income? Not necessarily. But they have certain information that is really easy to acquire. You know, age would be one of them.
so the stratification, I guess you'd say, is like all people on campus unless they're over a certain age, like for the parent thing.
Well, you'd say how many people on campus have children versus don't have children. You'd want that percentage. Now, if we're trying to find out, now let's say it's a money thing. Okay? My gosh, there's one going on right now in the United States, a huge money issue that does not affect the whole population. Does anybody know what it is? It's a huge money issue that affects folks, I don't know, similar to your age group stratification. What is it?
The student loan relief.
The student loan forgiveness thing. And I've read so many things. I have kids who have outrageous debt from student loans. They're all for this, but their student loans aren't federal. They're private because they couldn't get the federal loans. So there's a question of, are those even considered? So then the question is, you know, should they not be? But I was reading an article yesterday that said it was something like 13% of Americans have any form of student loan. And a lot of those go back for many, many, many years. And it also said that of those, there was a significant percentage that come from extreme wealth, which is why they had student loans, because they couldn't qualify for any financial aid. And so they talked about giving the rich folks who don't need it the relief. Well, you know, and so there's so much controversy. What the point is before we start handing it out generally, regardless of how you feel, it's like, I kind of need to know what percentage of the population is actually affected by this. If the percentage was huge, you'd say, wow, there's a lot of people affected. But if the percentage was really small, you'd say, you know, I don't know how, this is not a right or wrong question. This is straight up stratification. So when Americans are asked how they feel about student debt, which way do you think the polls lean? Towards for it or against it as a nation? Strongly against. Why? Because 87% of the population has no student debt and they are paying the bill for the student debt. That's why it's strongly against. That's why the only reason it would pass is because the government says, no, we're going to do it. What if half the population had tremendous student debt? What if most of the population had tremendous student debt? You know, so this is the whole thing about stratification. You have to know the percentages ahead of time. Otherwise, you can't make logical decisions based on stratification. So stratification, to me, it's a really huge thing if it matters. Now, if I just said, you know, I just would like to know the percentage of Mesa College students that are football fans. Do I care? Male, female, age group, political party, income status, ethnicity? Do I really care? Are you a football fan, yes or no? Do any of those things matter? No. So would I stratify that sample? No. Not unless I wanted to report, okay, this percentage of Mesa College women under the age of 19. You know, unless I wanted to give those type of statistics, I just want to know what percentage of Mesa students are football fans. There's no stratification necessary. None whatsoever. I want to know how many people voted in the last election. I don't need to stratify. Did you vote? Yes or no? See, there's sometimes there's no reason to stratify. Right? Are you a happy person? Yes or no? Now I'd like to stratify, you know, happy age groups and everything.
So how do you like verify those types of things? Like for the football thing, it's not as serious, but like for something else, like how would you verify like?
Be more specific, you mean like
So
that they're that age?
let's say for example, like someone says that they're religious, but they're not. Like they may only.
That's a tough one. Sometimes you have to just take it at face value because you're saying, for example, if I'm saying, I want to ask a political question, and then I said, well, what party would you associate with? Because I'm trying to keep track of how each party feels. I have to trust that you're going to tell me the truth, right? If anytime you're asked to put, who did you vote for in the last election, and I'm keeping a tally, I have to assume you're telling the truth because there's no really ulterior motive for you not to. But could you be lying to me? Sure. Would I know? No, not likely. So there's a little bit of trust involved there, but the nature of the situation, there's no logic to assume that you would not be telling me the truth. If I asked you how tall you were, or if I asked you how much money you made last year, if I asked you how heavy you were, if I asked you how old you were, am I always going to get the right response? Yeah, so sometimes I'd say, can I see your driver's license so I can see your birthday? I might do that one for the age. Because a lot of times, again, if you're telling me, I always have fun with this one, but you're telling me how heavy you want to be. Now, I have fun with this in the NFL. They have statistics on every single player, their age, their height, their weight. And you know what's really funny? The heaviest players in the NFL, the linemen that are way over 300 pounds, do you think their weights are reported accurately in general? The answer is no. Same thing in the NBA. The heaviest players, their weights are always underreported. Always underreported. Sometimes 20, 30 pounds underreported. Shaquille O'Neal, his weight was often up as much as 50 pounds underreported because they're already really heavy. Now, you have a smaller player in the professional ranks. He might be a wide receiver, it might be somebody 175, 180 pounds, or particularly a college player. Are their weights going to be underreported or overreported? Always the other way. They always make them heavier than they really are, and the really heavy guys always make them lighter than they really are. You absolutely cannot trust anything written. And I find it kind of funny. Tim Tebow. I remember Tim Tebow. When Tim Tebow played at Florida, he was 6'5", 260 pounds. Tim Tebow is 6'3", 240 pounds, about. But they overinflated his, and in his NFL career, every year I noticed he got a little shorter and a little lighter. Why? Because the people reporting, I'm using him as an example because I remember specifically he was huge, and then as his career went, how come he keeps getting shorter every year? Patrick Ewing, who's a Hall of Fame center for the New York Knicks, was 7'1" his entire NBA career. Patrick Ewing's 6'7". He played at 6'9", but over the years he's shrunk. I saw him interviewed a couple years ago, and they asked him how tall he is. He's about 6'7". And he sort of laughed. He was listed at 7'1" most of his career. Now, why would you lie about somebody's height by that much? Because in college he was listed at 7'1". And he played his whole NBA career at 7'1", even though he said he was maybe 6'9". Charles Barkley, everybody know who he is? The Chuckster. His whole NBA career he was 6'7". Charles is maybe 6'4" at the most. Maybe 6'4". And of course, my favorite, when I was growing up, my favorite wrestler, Hulk Hogan. You guys remember Hulk Hogan? You know what he was listed at most of his wrestling career? 7 feet tall. Hulk is a huge dude. I think at his tallest, he was about 6'6". But they listed him at 7 feet tall his whole career. And you never know because everybody's huge. So the thing is when you get to report it, it might not be all that accurate. So that's why you want to measure it. Now the third type, which is, this is kind of an odd one. The systematic sample. Now, I would like to sample San Diego County in a nutshell. And it's a really simple thing. I would like to know every single person in San Diego County who is listed in the phone book. By the way, in my entire lifetime, I've never been listed in the phone book. Just so you know, there's a lot of people like me who want to stay off the grid. I am the only person in America who has no social media. No Facebook, no Instagram, no anything. Never, not in a million years, would I ever put out information for strangers to know someday. I'm very private in that way, and people laugh at me, I'm a dinosaur, but, Anyway, the phone company would like to know Are you happy with how you are being listed? So are they going to ask me? No, because I'm not listed, so it wouldn't make any difference. Now, how many names are in the phone book? A lot, good. Good answer. Would you say tens of thousands at least in San? Yeah, there's a couple million people in San Diego County. There's a lot of names. How do I construct a poll? Do I walk around town and ask people? No, that would be crazy. I have a phone book in front of me. How about random selection through the phone book? But how would I do this? This is what a systematic sample is. A systematic sample, okay, is a sample where I decide I'm going to ask every 10th or 100th or 1,000th or 10,000th person in the phone book. But the problem is, let's say you are number 47 in the phone book. And if I start with number 1 and then I go to 101 and 201 and 301 and 401, did you ever have a chance to be selected? No. So let's just suppose I did every 100th person or every 1,000th person. Probably that makes more sense, every 1,000th person. The problem is only person 1, 1,001, 2,001 can be selected. Where does the random come in? The random comes in on choosing the starting point. There is something called a random number generator that every even cheap computer has. Imagine I have a bunch of numbers on a wheel and I spin the wheel, you know, and it stops at a particular number. All numbers between 1 and 1,000 are equally likely to be selected. You with me on that? 347 was the number selected. Now I'm going to start there and count by 1,000 and go all the way through the phone book until I run out of names. Did everybody have an equal chance of being selected? Now, yes, because the starting point was totally random. You could have been selected. Now, once the starting point's selected, then I just go through and select it. This is called a systematic sample. This is what you do when it's a absolutely huge database that you're starting with. And it is not possible to randomly go around and asking people questions. So if you've ever been called to any type of opinion poll over the phone, has anybody ever been called phones? I can't stand those. Sometimes they're product advertisements, sometimes it's politics. Before we did all of this, the Prop N and Prop S funds, before we did all of this stuff, there was a lot of polling going around because this was billions of dollars. This was taxpayers' money, and they, you know, before we put this on the ballot, we wanted to know, would people actually vote for this? And people did, but it took a long time. So I get a call, this is a long time ago, it's probably in the late 90s. I get a call and they said, I'm representing all of this and we'd like to know your opinion. Because basically, let's suppose they called 1,000 people throughout San Diego County and most people said, no, I am not for this. Then it never would have made it to the ballot. Because it costs a lot of money to do that. But if the majority of people said, yes, I'm overwhelmingly for all the new building and construction, we were the top community college in the United States, and we had arguably the worst campus in the United States. I taught classes for several years out of the old military Quonset huts. You know what those are? Those little tin cans? We had the worst labs. Our labs were built in the 60s, and we were still using them in the 90s and the early 2000s. They were ancient and not even safe. Our campus was so old and decrepit, and we finally, you know, got all this money to build these incredible buildings. So I get a call, and it was a long interview. It was like 20 minutes, 25 minutes of questions. And you know, are you for this? I said, yes, I'm overwhelmingly for this. And then the last question they asked me was, are you an employee of the district? And I said, yes. And they said, oh, I'm sorry, we can't use your response. Why? Because I would obviously be, the B word, biased. And I said, you know, you should have let off with that question. It was probably upwards of a half an hour. And they said, we can't use your response. Yeah, I have a bald spot where I pulled my hair out at that point. I thought, okay, this person really messed up badly. You know, has anyone here ever served on a jury? Or you've been in the process, and they ask questions. So they're about to do a case. So one of the questions they might ask is, anybody here, are you or is a member of your family, let's say, a police officer? That's one of the first questions they'll ask. Well, you're about to be on a jury where somebody is going to trial for a crime they're being accused of committed. Do you think being a police officer might make you biased in that case? Yeah, more than most things. Maybe it's something, it could be whatever kind of crime it was, there may be groups of people who are far more biased about that. So they'll ask, is anybody associated with this particular group? And if they do, they'll say, thank you, we're not going to select you. Because they want people who are absolutely neutral. You can't have any form of bias one way or the other. And that's a difficult thing to do because you can't control everything, but they want to make sure that it's not only a random sampling of your peers, that's what a jury is, but an unbiased random sampling of your peers. But in a systematic sample, I don't care who I'm asking because the question is in regard to, like I said, it might be about, are you happy with your phone service? It's a simple question, I'm just going to call you, okay? This one, I don't care about the groups, I just want numbers. But because San Diego is so big, so if I said I wanted one 1,000th, that would be 1/10%. I want 1/1000th of the people in San Diego County. Do I actually have to know how many people there are? No. I count every 1,000th person until I run out of names. That's it. Yeah, I don't have to know how many people. I just go until there's no more people. Does that make sense? So that's why this one is really, really easy. And a lot of times, there are a lot of people with access to the entire phone registry in San Diego County. There are a lot of people. You know this. I get probably 10 calls a day from these people. They're called robocalls. Anybody here get robocalls on their cell phone or their home phone? Yeah, it's a random selection of names throughout the phone book. You're called, there'll be a recorded message or when you say hello, there'll be a long pause and then the computer will kick on and some recorded thing will talk to you but they didn't know who they were calling. They didn't have to. Just random selection as they're going throughout the phone book. And they're going to do this all day, every day, all year round because they have access to the entire database. It's annoying, isn't it? So these are the 3 basic types of samplings that we typically look at. And those are the only ones we're considering. Now we're going to move on, start doing something numerical. Okay? So I'm going to talk about, this is the next chapter, something called a frequency distribution. There we go. A frequency means how many times something occurred. Okay? How many times did something occur? So I'm going to give you a really simple example. All right? At a particular auto dealer, we'll get kind of silly. We sold 100 cars last week. Okay? 100 cars were sold. But here's how we broke it down. We had 37 were blue, 25 were red, 13 were green, and actually let's make that 17 were green, sorry, and 21 were black. Because this is really important, right? And so we wanted to give a visual of the cars that were sold last week. Well, a blue car, there's no numerical value for blue or black or red, right? So this would be categorical, it would be nominal data. But I want to make a picture that reflects what we just did. So that's what I'm going to show you. So the first type is something called a bar graph. Everybody has seen one of these in some capacity. It's so easy to see, it's so easy to produce. It doesn't have a numerical value, but it's a quick visual of what just took place. So in my bar graph, now, when we talk about graphs, a lot of people are thinking algebra, XY plane, variables, slope of lines, all this. That's nice, but that's not the same kind of graph. We just want a visual representation. So frequency will always be on the vertical, how many times something occurred, with 0 at the bottom. And here will be my categories, my outcomes, on the horizontal. So I'm going to put blue. Well, actually, which, hold on, what did I put? Red, right? Green, black. Now, how many times did they occur? Well, what's the most occurrences you see? 37. So, should I put like 10,000 right here?
No.
Yeah, because then 37 would be barely visible. So that probably wouldn't be very good. Maybe I'll go like this. I'll call that 40, because then I can call that 20, and then... By the way, having graph paper makes this so much easier. just having simple graph paper. Now, how many blues were there? 37, so about here. So that's about right. How many reds? 25. So red about here. And greens, 17. Probably about there. And black, 21. Just above the 20. Okay. Now, you can color in those rectangles if you do whatever you want. So when you take a quick picture here, you look at this, can you tell what we did last week in terms of our auto sales? Yeah, oh yeah, blue was the most, you know, red and black. And I saw way more of these than this. I have a simple visual. There's no calculations going on. A bar graph is one of the simplest visuals. So you'll see stuff like this all the time. You'll see, you know, the bars, different heights. One of the most important things about this though, 0 has to be 0. Okay? You don't start at, you know, 100 or 50 or, no, 0 is 0, and then my highest one is my highest one, and then I have a scale that has to be accurate. In my picture, you know, this much is 10, and that stays the same. This is don't do this. This is a terrible graph. I have people do stuff like, all right, there's 10, there's 11, there's 50, there's 1,040. What do you think? Worst thing you've ever seen in your life mathematically? Probably. Wait a minute. That's 10 units and that's 1 unit? And that's 49 units and that's 990? What? No, each amount should be the exact same. You can't have randomness like that. Otherwise, it wouldn't make any difference. Now, a bar graph is a simple visual, but there's not a lot going on there. What if I wanted to do something that involved counts or calculations? Okay, that's the next thing. The most important type of graph we'll ever deal with is something called a histogram. Now, the difference between the histogram and the bar graph is the bar graph has gaps between the outcomes. The histogram, there will be no gaps. So every single thing will be represented. So my rectangles actually touch. And, well, I could make these touch. There's no numbers. Histogram, I will have numerical values, counts, taking place. So, here's what happened. I actually did this. I have certain experiments that I did, and you're going to do this on your next quiz. I'm not going to flip a coin. I'm going to flip several coins. And this is one of the things I'm going to ask you to do next day. In fact, you can actually do this at the end of class today if you have any change in your pocket. You actually have to have coins to do this one. You're going to flip, I flipped 3 coins at once. I believe I did 100 times. And so here's what I did. I did 3 coins once. And I counted the number of tails. Now, if I flip 3 coins at one time, is it possible that none of them come out tails? Yeah. Is it possible that all of them come out tails? And sometimes one, sometimes two. All of those are equally, I shouldn't say equally likely, all of those are possible. Okay, everybody go with that? So I did this 100 times, and then I just did a tally. When I got none, I put a tally in the 0. When I got 1, I put a tally in the 1. And so this is what you see. You see a lot of this, you know. This is what I mean. So when I was done with this experiment, okay, I got this about, let's see, I think this was 12, this was 10, hold on. This was 41 and this was 37. This is what I saw. I got 1 that many times, I got 2 that many times, I got 3 that many times, and so on. Yeah, and so I would like to make a picture that is representative of this. But it's not a bar graph because these are actual counts. I'm counting things. So the vertical will still be the frequency. The horizontal will now be the count. Okay? So I'm going to show you what that one looks like. Easy. It's easy to do. But we want to get it right because we're building on this to the more, there's a more complicated thing coming up. Okay? So 41 was my highest, so let's say that's 10, 20, 30, 40. Now, 0, 1, 2, 3. Now I want to make my bars be as high as the frequency. So 12, about here. Notice where the 0 is. It's in the middle of the rectangle, not the edge of the rectangle. I'll explain why. That's the biggest mistake people make, is they put it in the wrong place. Now, 1, 41. You notice 1 is in the middle of this rectangle. If I had made 1 the edge, then would your outcomes of 1 go in this rectangle or this rectangle if I make 1 the border? Does that make sense, everyone? If you make your outcome the border, then you won't know which rectangle to put it in. Make your outcome the middle. Then there's nothing to think about. Now 2, 37, about there. And then 3 was exactly 10, about there. Okay, this is a histogram. Not much different than a bar graph, except my outcomes in this case were smack dab in the middle. And what I want you to understand is the outcome is the middle, so therefore, what is that value right there? This will matter later when we start doing probabilities and things. This is actually really important. What is that value? If that's a 0 and that's a 1,
There's no value.
no, there is a value, because that would be 4, 5, 6. There's definitely a value. What do you think it would be?
It's half.
Yeah, that would be 0.5, and therefore that would be what? 1.5. So the rectangle that corresponds to an outcome of 1 actually begins at 0.5 and it ends at 1.5. This is actually really, really important. Later on, you'll see the importance of it. We're many weeks away from the calculation, but that's really, really important that I do that, because later on when I'm collecting data, those halves are really important. In a histogram, this is called a boundary. The vertical bar is called the boundary. A boundary cannot be a possible outcome. Because if the boundary were the possible outcome, then which rectangle does the outcome go in? So once again, I'm going to show you bad. Okay? This is bad. If this is 1, then where does the outcome of 1 go? Here or here? You see the problem? It's ambiguous. Where does the outcome of 2 go? Here or here? Oh, the outcome of 2 needs to be in the middle so that I can't get an outcome of 1.5. That's the whole point. So the boundary, where I draw the edges, has to be halfway between possible outcomes. Then there's no possible way I can misinterpret where to put an outcome. Does that make sense to start with? So the first thing about a histogram is we just simply do counts. This is called a frequency distribution, where I'm doing this. Now, what if? What if my numbers were really, really large? I didn't do this 100 times, I did this 10,000 times. And let's say that I did a lot of coins. Instead of having counts here, a lot of times we have decimals. We have, in other words, think percentage. Oh, so in this case here, I did it 100 times. What's 40 out of 100? Well, that's 0.4, isn't it? Or if you want to say 40%. So what if I do this? This is now because I did it 100 times exactly. This you could say is the percentage or probability. This is now called a relative frequency distribution. Relative generally involves percent. I'll give you a simple example. I love those questions. So I say, well, how did your test go the other day? You go, I got 87. Okay? Is that good or bad?
That's good.
No.
87 out of what? 87 out of 1,000. 87 out of 88. 87. that number 87 doesn't really mean anything to me, does it? Because I don't know, is 87 out of what? Well, what if you said I got 87%? Now does it matter how much the test was worth? No, you got 87% of all the possible scores. Oh, okay. So your score of 87, that's called your raw score. But unless I know how many were possible, I don't know how you did. 87% is called your relative score. Okay, relative. So how many here have ever worked a cash register? And so you understand, money and handling. And so let's say today you were off by $1. Is that good or bad at the end of the day? Because anybody who's ever done a cash register knows the only thing that ever matters is at the end of the day you balance perfectly. You're 5 cents off, you're still mad, aren't you? It's like, oh, how did they possibly? You were off by $1. Is that good or bad? Well, you only did $5 of business today. That's probably not very good. You did $25,000 of business today and you're off by $1. In other words, it's $1 compared to what? Oh, so the being off by $1 isn't enough. And one of my favorite examples is, okay, today on the job, you were off by 20 centimeters on your job. You were off by 10 centimeters on your job. Who had a better day at work? Good. Oh, this guy here, he does construction and he had a beam going across a skyscraper, a beam that was 300 meters long, and the end of your beam was off by 20 centimeters. You were so mad. 20 centimeters in a 300-meter beam. That's really, really small. She was performing open heart surgery today and was off by 10 centimeters, which is about the size of a heart, and therefore the patient didn't make it because the heart's only about 10 centimeters across. So in other words, you were 20 centimeters over 300 meters, you were 10 centimeters over 10 centimeters. So your percentage error was microscopic, yours was 100%. Does everybody understand? That's called the relative error. That's far more important, is the relative, saying it's not just the sheer amount, it's the sheer amount compared to, so like the test score example. To say I got a test score of 87 is only meaningful if it was out of 100, but it might have been maybe it was out of 80 and you got extra credit. So now you're over 100%. So just simply to give the raw score sometimes. Or how much were you off today? Well, it kind of matters compared to what? Right? It'd be kind of like saying the cop says, you were going 52 miles an hour. Is that good or bad? What does it depend on? What was the speed limit? Oh, the speed limit was 55. You're good. You were in a 25 zone. You're bad. So just giving you the speed isn't really important unless I know what I'm comparing it to. So that's called relative. So in this situation here, this was easy because that's 0, 1, 2, 3. What if we're talking about income in the United States? Now, I don't know the exact number now. I used to know this, but it changes every few years. I believe, I could be wrong, I believe there are 6, it might be one more, might be one less, different income brackets. In other words, $0 to this many dollars is the first bracket. And then that many to this many is the second, and then the highest income bracket is anybody who makes more than, this amount. And the reason income brackets are important is that's how it determines how much tax you're going to pay, what percentage. Okay, so I've got 330 million Americans, and everybody is in an income bracket. Do I have every single dollar represented on the... Boy, that would be a really big graph, wouldn't it? $1, $2, $3, up to, millions of dollars, billions of dollars. I read yesterday Warren Buffett is worth $103 billion. That's a really big piece of graph paper, isn't it? Or maybe we say, from here to here is 10,000, from here to here is 20,000, something like that. That's probably more reasonable. In other words, I don't have every single unit represented. It's too much. So now I have intervals. Okay? So when we're talking about intervals, we do the exact same thing. We make our boundaries halfway between attainable values. Halfway between. Therefore, I know where to put every number. So let me give you a really simple example. So we're going to do a histogram that has a little more going on. All right, so let's say in a particular class we had an exam, All right, let's say here were the exam scores. And by the way, I have to have these sorted. And a lot of folks say, well, is that a lot of work? How much time does it take for your computer to sort things when you sort? Anybody? Like 1/100 of a second? Any time I put numbers down and I just did sort, everything's sorted. Sorting is like the simplest operation any computer can do. So I have a bunch of exam scores, they're sorted. I'm gonna go top to bottom. So let's say my exam scores on a 100-point exam. Let's say they were as follows. 98, 97, 94, 90, 89, 89, 86, 85, 84, 83, 80, 79, 78, 78, 78, 74, 73, 72, 70, 69, 67, 66, 63, 61. Let me do one more. 59, 57, 56, and how about, let's say, so 52. No, 50, sorry, 50, trying to make this work fairly nice. Okay. 28 students took an exam. These were their exam scores. I would like to give you a visual representation of how the class did. So do I want this to go 0, 1, 2, 3, 4, 5, 6, all the way up to 100? Then you'd have a lot of rectangles that were 1 high, wouldn't you? Does that make sense? What would make more sense? Maybe lumping the A's, the B's, the C's, the D's? Would that make more sense to do something like that? Yeah, you're like, okay. But the only problem with that is you might call an A 90 to 100, 80 to 90, and so on, but then the F range might be bigger. So another way of doing this is just literally looking at the whole, and I'm going to walk you through the process. Because I've asked you a question on the quiz that's very similar. So first of all, what is the range of values? It's 98, 54. So what is my range of values here? It would simply be 98 minus 54, which is what? 44. From top to bottom, it's 44. So when I set up my histogram, do I really need anything from 0 to 50 to show up on my histogram? No, because nobody's in that range of values. So my histogram is really going to go from the low to the high. Now, let's say I want 5 classes. Classes means literally 5 rectangles. I want 5 groupings, 5 ways of separating. But I want them to all be equal in size. So what we do, first of all, we say, I go an extra half a unit above, I go an extra half a unit below. Remember, 0 started where? Technically at negative 0.5, didn't it? And where did 3 end? 3.5. So you always go an extra half in each direction. This is not common sense until you do a few problems, then you realize why you're doing this. Go an extra half in each direction. So technically, you're really going 98.5 minus 53.5, and that's 45. Now, in a perfect world, that's exactly a multiple of the number of classes that I have. Oh, that makes it nice. If it's not, then you have to make them a little wide. Don't worry about that. So, I have 5 classes. I have 45 from top to bottom. Then exactly how wide should each class be? 45 divided by 5.
9.
So what's 45 divided by 5? It's exactly 9. All right? So my class width is 45 over 5. And by the way, the 5 was an arbitrary choice. But most histograms, this is one of those things you will learn in stats, but really it's more of a practical thing. If I'm giving you a histogram, would you like to see a histogram with 100 rectangles?
No.
It's too much information. I can't decipher it. Do you want to see a histogram with 2? No, it's too compact. So most histograms will usually be between like 5 and 10 at the most. Rarely will you have as many as 10, and rarely will you have fewer than 5 if I'm doing large groups of data like this. Again, I want a simple snapshot. I just said, for example, income brackets. I think there's around 6. They're not 25 or 50 or 100 income brackets. There's just a few. Then you can really quickly look and see the spread across the country. It's really easy to look at it that way. So I have 9. So what I'm now going to do is figure out what are my boundaries. Now you can either start at the top and go down or start at the bottom and go up. It doesn't make any difference. I generally like to start at the top. So if my highest number is 98.5, what's 98.5 minus 9? Again, get out your calculator, Captain. 89.5. We agreed our highest number we're going to see is 98.5, and I have a class that's of width 9, so it's going to go from 89.5 to that. Now, here's the great thing about histogram. Where is the next class going to end? At 89.5. No gaps. So where will this one start?
80.5.
80.5, perfect. And this one will end at 80.5. Where will it start?
71.5.
71.5. This one will end at 71.5, so where will it start?
69.5.
62.5,
62.5.
there we go. And then finally, this one ends at 62.5, so it starts at 53.5. And notice, counting by nines, have we covered every single score? Yes. Would you say it's now safe to say that every one of these scores will fall into exactly one category? There is no score that can possibly fall into 2. When you're doing your taxes and you have your income, you cannot fall into 2 different tax brackets. You can't. Because if you did, then you'd probably, the higher one, you'd have to pay more taxes. No, you can only fall into one tax bracket. So anytime you're doing this, this is not a stratification, this is actually simpler. I'm just doing all these cutoffs. So now, here's what I like to do. I'm going to go over to my thing here. Where are my cutoffs? 89.5 is halfway between here, so that's it. That's one of my classes is right there. All right. 80.5. Do you agree that would be the cutoff? 80 is below 80.5. 83 is above 80.5. Okay, next cutoff. 71.5. 70 is below, 72 is above. Next cutoff, 62.5. And that's it. There's the first class, there's the second class, there's the third class, there's the fourth class, there's the fifth class. Okay? So, how many are in each class? The reason I did that little cutoff, it makes the count real easy. Okay? So how many are in the first class?
4.
4. How many are in the second class?
6.
In the third class?
8.
In the fourth class?
6.
Oh my goodness, I didn't realize it was come out this.
5.
It's 5.
Oh, hold on. We got a problem. It's not going to add up. So you have 4, 6, 8, 5. 5. There we go. And 5. Now, don't go any further until you add these up. What does this add up to?
28.
28. Is that important?
Yes.
Yeah, I have 28 scores. If this doesn't add up to 28, we got a problem, right? Either we left somebody out or we overcounted somebody. Always add up your frequency to make sure it adds up to what you have. Now, this is where my picture is going to come from. Okay? So, when I draw, when I do it, what is the highest frequency I have?
9G. Oh, wait.
8. So when I'm drawing this, make 8 really high. Don't, let me put 8 right here. What's the problem? That I can't see anything, everything's too squished. No, I'm gonna put 8 way up here. Then that would be 4, and 2. Does that make sense? This will make my visual so much easier. Now you can number every one or maybe number every other one, it doesn't matter. Okay, what's gonna go on the horizontal? Starting here, the lowest one is 53.5. Wait, where's that coming from?
I think it's the volume of the computer probably is turned up.
But it's funny, I don't have it on. I have it on email. I don't know what that is. All right, so we're gonna put 53.5 right here. Then we're gonna put 62.5 right here. And by the way, evenly spaced. Question?
Yeah. Never mind. I
One of
was
those-
thinking on those, on the point bounds is where the point is gonna end.
So it's the boundary.
It's the boundary, it's not gonna go in the middle, right?
No, the 0.5 is the edge of the rectangle. Because you
Yeah.
can't get a 0.5. Therefore, my boundary, I like to use the term, it's an unattainable score.
So I have another question. What's gonna go in the middle? What's gonna go in the middle?
Oh, in the middle, hold that thought. That is an excellent question, because it's not obvious yet, but I want it to end up being obvious at some point. So right now, my first was 5 units high, so I'm gonna go from here to here. Boom. You with me? Then my second one is what? 5 units high, okay? My third one is 8 units high. My fourth one is 6 units high. And the last one is 4 units high. Okay. Is this now an accurate depiction of how the class did in terms of the test? You can look at this and go, oh yeah, okay, this is the highest, more. It's not like earth-shattering and groundbreaking, but it's a simple visual. Now, all of my boundaries, these are called boundaries, were scores that could not occur. You couldn't get 62.5. You could get 62, you could get 63. So clearly you can fall into a category. Now, you were asking what goes in the middle, and by the way, there's 2 ways histograms are typically represented. Either by the boundaries, which might not be totally comfortable because you go, those are all weird numbers, or by the score that goes in the middle. My first histogram, 0, 1, 2, 3, I gave you the outcomes in the middle. Why? Because there were no other numbers to put. Anybody want to guess how we figure out what goes in the middle of these two? I'm looking for a word.
A, grades, A, B, C, D.
No, what?
Median?
Average.
The average.
Yeah.
Oh, so let's say, by the way, you're not going to see a histogram with that number, and the one in the middle. Why? It's too much information. But if these were income brackets, I probably want to see what is the end of each income bracket, because then I know where I'm going. But if I'm just trying to get a quick look at how a group did, I might want this number, this number, this number, this number, this number. Get out your calculator. What's halfway between these two? So add those up and divide by 2.
58.
So I'm going to write it. That's 58. Oh, and by the way, I just have to count by 9s now. I don't have to actually average each one. Remember, everything differed by 9. So this will be what? 67, 76, 85, 94. So that was the right question to ask. What goes in the middle? So a histogram, and by the way, both are fair game. So it's good to know how to do both, because it's really up to you. How do you want to represent the data? So these numbers here are actually called the boundaries, because they are the edge of the rectangle. A boundary cannot be a number you could have gotten. So in this case, the boundaries can't be whole numbers, because then I wouldn't know which rectangle. But what this tells me is that this group on average, the first group on average had 58. This group on average had 67.
I don't know if he was about to ask this, but can you do it? Can you have a histogram just like that with the boundaries and the numbers?
Yes, you can. But would you say that's busy?
Choppy, yeah.
It's absolutely correct. And a lot of textbooks will do both. I just find it, the way I did it down below, if I put all those numbers on the same line,
It's all jumpy.
it's hard, yes. It's what I call the Matrix movie. Remember? You guys seen the Matrix movie? You know, all the numbers coming down? When it starts looking like that, it's too much information. The idea is this is supposed to be useful, and it's supposed to be something that you can take a glance at. Now, here's one of the huge advantages to doing this. This is what the IRS does. Okay? There's 330 million Americans. At least 230 million Americans are going to file their income taxes. That's a lot of people. Can you imagine having to keep track of every one of them and trying to find numerical averages and all those kind of things and how much taxes are paid? That would be mind-boggling. So here's one of the things that is actually done. We had 5 scores in here. If I wanted to find some sort of numerical average, obviously I would add up all these and divide by 28. You agree? What if actually there were 330 million of these? Do you really want to add them all up and divide by 330 million? Probably not. So what they often do is say, treat this as everybody in this group had this score. Treat this as everybody in this group had this score. Treat this as everybody in this group had this score. Then I can find the numerical average of 330 million Americans in about 30 seconds with a cheap calculator. Because I'm treating it as literally there were, in this case, 5 values. Does that make sense? So the advantage to putting the one in the middle only is that I can pretend loosely that everybody got that score. And actually, that's not a bad way of doing things when you have a huge, huge number of scores. These guys, again, these guys are called the boundaries. They are the boundaries of my rectangles. They are on the edge. That's kind of a no-brainer. That works. These guys here, this is strange. It was the middle value. It was the numerical average. They are called the class marks. I don't know where the word comes from, to be honest. That's what they're called, though. So the mark would be the middle, the boundary would be the edge. And it's good to know how to find both, but in your representation, you probably don't need to put them both down in your picture, just because, like we said, it can get a little cluttered. Now, if my rectangles were ginormous, yeah, I could put all the numbers in. But you're talking about reading something that's probably smaller. So this is actually up to the statistician. Which way do I want to represent it? And it really doesn't make any difference. Now, all of you told me the class marks from the boundaries by just taking halfway between. What if I only gave you these black numbers? Could you find the boundaries? Yeah, find the average of those two numbers. Does that make sense? Oh, that's why I don't necessarily need to put all of them on there. If I gave you the boundaries, the class marks are the average. If I gave you the class marks, the boundaries are the average. So it works both. So therefore, you only need to do one. You guys with me on that? Pretty neat. All right, we're going to take a short break because we need to take a break, and then we're going to practice. And like I said, some of you came in a little late. The publisher sent me the 6th edition ebook. They didn't realize they'd sent me the 7th. I didn't realize it until literally the first day of class. I thought it was the 6th because the picture's so darn small. So if you have your laptop, go ahead and access it yourself. I'm going to bring it up here, but if you want to do it, you don't need to follow this because we're also going to do problems like we did last day. We're always going to practice problems because I don't want anybody leaving without having a thorough practice. That's the point of this class, is that literally you can get everything done today. You almost, except like exam prep, when you want to study for an exam and review, you're almost never going to have to take work home in this class because we have so much time. Okay? Petra? Yeah, stop recording. Sorry.